Now let us see the question. An ideal gas is kept in a long cylindrical vessel fitted with a frictionless piston of cross-sectional area 10 centimeter square. Right. Now basically there is a vessel, cylindrical vessel, right? Something of this sort. Now the piston, it has certain piston. This is basically the piston, and whose area is 10 centimeter square, right? And mass is 1 kg, right? M is 1 kg. Now the length of the gas column in the vessel is 20 centimeter. L is equals to 20 centimeter, right? The atmospheric pressure is 100 kilopascals. From outside it is 100 kilopascals, right? Now the vessel is taken into a spaceship revolving around a satellite. First of all, let's just note it down, all the things, right? So if I talk about at this point, the pressure, total pressure, P total would be equal to what? Mg by A, because there will be a force pressure due to the weight of the piston, plus P naught, because P naught is acting downwards and weight is also acting downwards, right? So this would be equal to 1 into 9.8. Now what is area? 10 centimeter square. We have to convert it into meter square, which will be 10 raised to the minus 4 we have to multiply, plus 10 raised to the power of 5 pascals basically. So this will be the total pressure, which would be equal to 9.8 into 10 raised to the power of 3 into plus 10 raised to the power of 5, which would be equal to 109.8 into 10 raised to the power of 3, right? So this is the Newton per meter square. This is basically, or pascals I can write, this is the total pressure at this point. And the volume would be given by what? L into A, right? So all these things are given. Now let us see, this was initially and this was afterwards, or you can say finally basically. Now it is saying that the pressure, the vessel is now taken on a spaceship revolving round the earth as a satellite. That means at this point G would be equal to 0. That means Mg would be equal to 0, right? So there will be no pressure due to this thing, due to Mg by A. There will be no. Now the air pressure in the spaceship is maintained at 100 kilopascals. So that means the total pressure at this point, Pt, would be equal to 10 raised to the power 5 pascals or Newton per meter square. Now it is saying find the length of the gas column in the cylinder. So basically we can again see that no molecules has left the cylinder. So that means number of moles initially would be equal to number of moles finally, right? So this will mean that the temperature is also, because since the temperature is not given, so we can say that P1 V1 should be equal to P2 V2. We can assume that the temperature would be same, right? So that means P1 would be equal to what? 109.8 into 10 raised to the power of 3 into what is the volume earlier? 20 into A. This would be equal to final pressure, which is 10 raised to the power 5 into L dash into A, right? L dash is the final length. So we can cancel A and A, and from here we can easily see, if we solve this equation, that L will come out to be, L dash will come out to be nearly equals to 22 centimeter, right? So this is the answer. So basically, as you have seen, in all these questions, in all the questions that we are solving, we're using just one concept, that the gas is not going out nor no gas is coming in. So that means the number of moles remains conserved, right? So you have to basically use this equation. That's it.